Power of the lens. Now we have learnt that convex lenses converge the rays of light, and hence they are called the converging lenses because they converge the rays of light. To understand the power of lens, let us take these two examples. In the first case, I have a convex lens whose focal length is 1 centimeter, which means if rays of light are parallel to this lens, after refraction they will all converge at the focus, and this focus is 1 centimeter. So they will converge in this small distance. But if I take the other lens, here the focal length is 3 centimeters, which means rays that are parallel to this lens, here these all rays are parallel to the principal axis, after refraction will all come to the focus. They will converge at the focus, but they will converge after a longer distance, that is of 3 centimeters. Here they converge within 1 centimeter. So if I asked you the question, which converges the rays faster, and you would say definitely lens 1. Lens 1 converges the rays within 1 centimeter, but lens 2 converges the rays in after 3 centimeters. So the power of lens 1 is greater than power of lens 2, because lens 1 converges light much faster than lens 2, and the reason is the focal length of 1 is less than focal length of 2. Larger the focal length, less is the power, because it converges. If the focal length is large, like in lens 2 it was 3 centimeters, hence the power will be less. More the focal length, less is the power. So the power is defined as, if we say what is power of lens, we can say is a measure of the degree of convergence or divergence of light rays falling on it. When it comes to concave lenses, we will talk about divergence. If I have a concave lens, the rays that come parallel will diverge, and they will all appear to come from the focus. But if I have a thinner concave, the rays that come parallel, the divergence will be less, because the focal length is longer. More is the focal length, less will be the divergence. The power of the lens is defined as the reciprocal of its focal length in meters, which means power of lens equal to 1 over focal length of the lens, but that should be in meters. So we can say that P equal to 1 by F. There's another important point we can observe here, that power is inversely proportional to focal length, which means if focal length is less f, greater power, and larger f, longer f, more focal length, less power. Now we have to give an SI unit to power, and the SI unit of power is diopter, denoted by D. How do we define 1 diopter? We know P equal to 1 by F. Now if F equal to 1 meter, then P equal to 1 by 1, that is P is 1 diopter. So 1 diopter is defined as power of lens of 1 meter focal length. If a lens has 1 meter focal length, its power is 1 diopter. Now when it comes to concave lens, we know the power, the focal length is negative. So power will also be negative because power is 1 by F. But for convex lens, focal length positive, so power will also be positive. A convex lens has focal length 10 centimeters. So focal length, that is F, equal to 10 centimeters. What is its power? So you know the formula for power, equal to 1 by F, but the F should be always in meters. So this I've got to convert into meters. 10 centimeters to convert into meters over 100 meter. So this will be now 0.1 meter. So power equal to 1 over 0.1. So remove the decimal, 10 over 1. So power equal to positive 10 diopter. Now why positive? Because it is convex. The power is plus 10 diopter. A person having a myopic eye uses a concave lens of focal length 50 centimeters. So I'm dealing here with concave lens, focal length equal to 50 centimeters. Now concave focal length is always negative, so I put negative. And remember, when I'm calculating power, my focal length has to be in meters. So this will be minus 50 over 100 meter. So when I cancel this, it will be minus 1 by 2 meter. Now I need to calculate the power of the lens. So power equal to 1 by F, but it should be in meters. So that will be 1 over minus 0.5, or we could put it as minus 1 by 2. So this power will be 2 by 1 diopter. So the power of the lens will be minus 2 diopter. Remember, this will be a diverging lens. Concave is diverging lens. A thin lens has focal length minus 25 centimeters. What is the power of the lens and its nature? So focal length equal to minus 25 centimeters. For power, we need to work in meters. So 25 over 100 meter, which is minus 1 by 4 meter. Now we need to find the power. So we know power equal to 1 over focal length in meters. So the power here will be 1 over minus 1 by 4, which is minus 4 diopters. So power equal to minus 4 diopters. The very fact we got negative here, it must be concave lens. Concave lens are diverging lens. So this is a concave diverging lens with power 4 diopters. The power of a lens is plus 2.5 diopter. What kind of lens is it and what is its focal length? So power equal to plus 2.5 diopter. Now because it is positive, it is convex lens. Power is positive, convex, and convex lens are converging lenses. So the nature of this lens is converging. Now to find its focal length, we know power equal to 1 over focal length in meters. So 2.5 equal to 1 by f. So f equal to 1 over 2.5, 10 over 25 is f. If we cancel this, our f will become 2 over 5, but this is meters. If I want to make it in centimeters, 2 by 5 into 100. And the focal length here, this will cancel out, is 40 centimeter. So this is a converging convex lens with focal length 40 centimeter. A lens has a power of minus 2.5 diopters. What is the focal length in the nature? Power is minus 2.5 diopter. So we know power equal to 1 over focal length in meter. So 2.5 minus equal to 1 by f. So f will be 1 over minus 2.5. So we remove the decimal, negative. So we have f equal to minus 2 over 5. This is in meter. If I want to change into centimeter, into 100. So f will become minus 40 centimeter. Now this is negative. Therefore, I can say the lens is concave. Concave means it is diverging. Concave lenses are diverging lenses, and it has focal length 40 centimeters. It is negative because it is a concave lens. It's on the left side of the focus is on the left side of the lens. See, rays, when they are parallel, they diverge, but they all appear to come from this point, which is on the negative, on the left side. Hence the focus is negative. Find the power of a concave lens of focal length 2 meter. So focal length equal to 2 meter and minus 2 because it is concave. So power is 1 by f. So power is 1 by minus 2. It's already in meters. So it will be, so power equal to minus 0.5 diopter. A convex lens forms a real inverted image of a needle at a distance 50 centimeters from the lens. If the image is of the same size as a needle, where is the needle placed? Now this is very important. This is a clue. It's of the same size. Image is of the same size, which means object is at 2f, that's when we get same size, and image is formed at 2f on the other side. This always happens when it is of the same size. The object is at 2f and the image is also at 2f. Now here they say that it forms an inverted image at a distance of 50 centimeters. That means image distance we know is 2f, which is equal to 50 centimeters. They told us image distance is 50, so f will be 25 centimeter. It is positive because convex. We need to find the power. To find the power, we have to convert the f into meter. So f will be 1 by 4 meter. So power we know is 1 by f. So power is 1 over 1 by 4. So power is 4 diopters. And positive because it is convex. So the power of this lens is plus 4 diopters, and we know where the object is kept. Object is kept at 2f.